Welcome to Chapter 5, Triangles and Congruence. This lesson is about classifying triangles. By the end, we should be able to classify and draw triangles by their parts. First, some vocabulary. A triangle is a figure formed by three non-collinear points connected by segments. Most of us are very familiar with what a triangle is, so I really want you to think about the definition, the actual definition of a triangle, and make sure you understand it. It's a figure formed by three non-collinear points, all connected by segments. Vertex is also a word we have heard before in math class, especially in geometry. As it applies to this lesson, is really one of the non-collinear points where the segments intersect and an angle is formed. So let's talk about how to name, classify a triangle in general. So the first thing you're going to need to do is take your triangle and label it. Let's put an F down there, a D up top, and E on the bottom right. And when we name these things, we have options for naming it. It has to start, first of all, we're going to use the triangle shape there, and we'll say triangle D. If I start with D, then we need to go in a clockwise position. So D, E, F. And this matters because if I tell you I want you to draw triangle DEF, then they need to be in the same order. Your other option would be to start at triangle E, but then you need to continue on with E, F, and then D. Again, starting at E, going to F, and then to D, continuing with that clockwise motion. If I start with vertex F, then it would be F, D, E, and that's how I'm gonna name it last. So triangle F, D, E. So in other words, you don't want to go counterclockwise. You want to make sure you are going clockwise. It does make a difference whenever we get to shapes that have more than three sides in later lessons. There are three sides of the triangle, and their names are side DE, EF, and DF, and they are segments, so make sure that you have that, just the line segment above the two letters. Vertices is the word we use for plural vertex. So the vertices in this triangle are D, E, and F. I do have commas in between them, otherwise we are naming the shape or a plane. So please make sure we are putting commas so they are separate: vertex D, vertex E, and vertex F. Lastly, the angles come from the vertices because the vertices are where angles are formed. So we have angle D, angle E, and angle F. And those are the parts of the triangle, the sides, vertices, and angles, and these are how we would name this particular triangle. So that was naming triangles in general, and now we're going to really start looking at how to classify triangles. And the first set of classifying, the first classification is by their angles. One type of triangle is an acute triangle, and that just means that all of the angles are acute. And we just remember that that means that it's less than 90 degrees, so less than 90 degrees. So this symbol here is a less than symbol. This is my angle. So all angles are acute, which means that they're less than 90 degrees. So if you look at these, all three of these angles are acute angles. An obtuse triangle is one that has just a single one obtuse angle, and that's going to be located right here. This one's greater than 90 degrees. Both of those are acute. So only one obtuse angle makes an obtuse triangle. Our final classification by angles is a right triangle, which we are all familiar with. The right triangle has the 90-degree angle, so only one. A right triangle has one right angle. So this should make sense. It's when we're classifying triangles by their angles, there are only three types of angles. There's an acute angle, obtuse angle, and a right angle. And I guess there are straight angles also, but you can't have a straight angle and create a triangle. So these are the three that we can use to classify triangles. Next classification for triangles would be to classify by their sides. And the first type of triangle is a scalene triangle. A scalene triangle is where none of the three sides are congruent. So we label congruency, remember, with our tick marks. So since this has one tick marks, two, and then three, it's telling us that none of the three sides are congruent. Isosceles triangles is when there are two sides that are congruent. Again, using the tick marks to identify which sides they are. Finally, the equilateral triangle has all three sides congruent. Equilateral, would be the part of the word that means equal. Lateral is referencing their sides. So equilateral means equal sides. All three sides are congruent. And that's our classification by sides: scalene, isosceles, equilateral. None of them are congruent, two of them, or all three of them are. Since the triangles are made of the sides and the angles, and that's also how they are classified, they can be classified in that way separately. However, most of the time we are given enough information to classify them using both. Classifying this example by sides and angles, these are our choices. The red is our angle choices and the green is our sides. So if we look at our information here about the angles, we have 40 degrees, 70 degrees, and 70 degrees. Well, based on that, they're all acute angles. So we have acute, and then I have two sides that are congruent, which would make this isosceles. So our answer for classifying this is that this is an acute isosceles triangle. In this example, we have a right angle, so it's a right angle triangle, and the sides, there are no tick marks, but they are labeled as a 3, 4, and 5, which means that none of them are the same. So this classification is a right scalene triangle. Lastly, we have one angle that's marked as 130 degrees, which is definitely above 90, so that's obtuse. And again, looking at our sides, none of them are the same, which makes that scalene. So we have an obtuse scalene triangle. And that's how we classify by sides and angles. Taking a closer look at equilateral triangles, because they are equilateral, which means that all three of their sides are the same, everything ends up being equal actually because of all the angles then being the same. And this has to do with the fact that since they all have the same sides, they end up using the same angles to create those sides. So when you have equilateral triangles, everything about them is equal. And taking a closer look at isosceles triangles, I'm actually going to go ahead and label this one. There are two sides that are the same. Those two sides that are the same are actually called legs, and the side that is not the same is called the base. The angle that is directly opposite the base, that is in between the legs, is called the vertex angle, because it's just identifying that one as being the one in between the legs. And the last piece here, dealing with angles, it says that the two angles opposite the sides that are the same. Well, that is actually referencing these angles down here on either side of the base. Those angles are the same. So notice that I've labeled them with two arches. So when we have an isosceles triangle, the two legs are the same. The base is the side that is not the same. The angle opposite the base is called the vertex angle, and the angles opposite of the legs are congruent. Again, if you think about this angle creating this leg, this angle has to create that same leg length in order to be isosceles, so it's going to have to be that same angle measure. So these base angles are the same as these legs are also congruent, so it's just the opposite sides set of information given to us from an isosceles triangle. So this concludes the lesson about classifying triangles. You have by angles can be classified by acute, obtuse, or right. You cannot have an acute right triangle or an obtuse right triangle. It's acute, obtuse, or right. And same thing with the sides. You have scalene, isosceles, or equilateral. They cannot be scalene, equilateral, or scalene, isosceles. You pick one of these and it can go with one of these. So you can have an acute equilateral, you can have an obtuse scalene, but you pick one type of angle to classify and one type for the sides.